Find the year N, which maximizes the equivalent annual cash flow. In this problem, an investment is made for an initial payment, which is a negative cash flow of $40,000. We'll assume this investment is for a truck. We are also provided a table of values which identifies the cost of maintenance on the truck for the first 6 years, as well as the salvage value on the truck for the first 6 years. On the cash flow diagram, we are instructed that the maintenance cost and salvage values should be applied at the end of the year. Lastly, we are provided that the annual interest rate, I, equals 9%. The problem asks to find the year, N, which maximizes the annual equivalent cash flow, or amount. Since our answer must be either 3, 4, 5, or 6, we'll compute the annual equivalent cash flow for these 4 possible solutions and choose the year with the largest equivalent annual cash flow. We'll begin by computing the equivalent annual cash flow for N equal to 3. Therefore, our cash flow diagram will include the initial cost of the truck, P, the maintenance cost of the truck for the first 3 years, plus the salvage value of the truck at the end of the 3rd year. The cash flow diagram for N equal to 3 is shown here, and an equivalent annual cash flow would be a constant quantity, A, paid back at the end of each of the 3 years. This value of A is equivalent to the sum of all other cash flows in the diagram. We'll call this value of A, A3. A3 equals the equivalent present value for 3 years, P3, times the appropriate discount factor. This discount factor can be looked up in a table after plugging in 9% for I and 3 for N. This discount factor equals 0.3951. The equivalent present value cash flow, P3, equals the single cash flow at the beginning of year 1, which is equivalent to all other cash flows in the diagram. Therefore, P3 equals negative $40,000 combined with the present value equivalents of negative $2,000 after 1 year, negative $4,000 after 2 years, and positive $16,000 and negative $6,000 after 3 years. Using an interest rate of 9% for all 3 discount factors, we look up the appropriate discount factors from the table of values, and P3 equals negative $37,480. Now we can solve for A3, which equals negative $37,480 times 0.3951, which is negative $14,808. Next, we'll compute A4, the equivalent annual cash flow for N equal to 4. This time, our cash flow diagram will include a 4th year of values, and the equivalent annual cash flow, A4, will be paid back over 4 years instead of 3 years. The equation for A4 equals the equivalent 4-year present value times the appropriate discount factor. Using 9% for I and 4 for N, the discount factor equals 0.3087. P4 equals negative $40,000 in addition to the equivalent present value cash flows for the following 4 years. Using an interest rate of 9% and the discount factors are looked up in a table of values, and our value for P4 is calculated to be negative $46,293. This makes the 4-year equivalent annual cash flow equal to negative $14,291. So far, we have computed A3 and A4, but we still need to compute A5 and A6. The cash flow diagram for n equal to 5 is used to again compute the equivalent annual amount A5 based on the equivalent present value P5. After plugging in the appropriate discount factors, P5 equals negative $55,177, which makes A5 equal negative $14,186. Lastly, for n equal to 6, the equivalent annual amount, A6, is computed by first determining the equivalent present value, P6. After looking up the discount factors, the equivalent present value, P6, equals negative $64,088. This makes A6 equal to negative $14,285. Now we can look back at the equivalent annual cash flows for time periods of 3 years through 6 years, and the maximum value equals negative $14,186, which corresponds to n equal to 5. When reviewing the possible solutions, the answer is C.